Well, howdy, physics sleuths and inquisitive souls, and welcome again to yet another lecture of dynamic gravity. So, as you may be aware, 2 weeks ago I released to you a data dump of my heavy neutrino and neutrino oscillation theory. And I waged war on the standard model utterly. Not one fuck it with my dick hanging out. That's who I am. And what you don't know is that I have a secret weapon up my sleeve. You see, I bumped my head a long time ago when I was a child. And when I woke up, I had to take a test. Some bullshit math test, doesn't matter. And I noticed during this test, I had an imaginary octopus friend that was with me now and forever. And you can't see him, but he's always with me. And he knows everything. He's really fucking smart. And if I ask him a question, he'll lie to me, because he's an asshole too. But if I threaten him, like to cut off one of his arms if he tells me the wrong answer, then he always gives me the right answer. And that's why I always know I'm right. And you can't see my invisible octopus friend. You don't know that right now I think he's sitting on top of my head. You can't see him unless you're crazy like me. That's the deal. All I know is that he will never, ever leave me because I am that important to him. Right. Well then, I guess it's time to get off our high horse and get into this rabbit hole of neutrino oscillation theory. But you know me, first I gotta have a little bit of boozy woozy to get me in the moody woody. Just a little bit, not too much, just a little bit. Okay. So, today we're going to finish my theory on neutrino oscillation that I have had a friend help me with. He didn't help me a whole lot, to be honest, but he did do one important thing that I really needed. He motivated me to do this, and for that, I am eternally grateful, and so I consider him a co-conspirator to this. To you, fertility, our neutrino oscillation theory, which I'm currently almost done writing the paper. It should be published hopefully soon. So, it'll be my fourth peer review paper. No one's ever really read any of them yet. They're all linked in my description in the archive if you care. I mean, they explain the whole universe. I literally hand-waved all of your laws of physics into existence with my giant penis. And I know I'm right, because the invisible octopus told me so. But before we do that, there's something I want to show you. So, those of you may know that I'm cray-cray, and every time I look up in the moon, I see this fucking moonfire, like burning the moon. And I've been unable to capture a really good picture of this, right? And these are probably like the best pictures I had so far. Like this one, is probably the best. You can see there's clearly additional light emanating from around the shape of this moon, that is clearly, larger than the moon itself. Showing that there's definitely something like the effect I'm going on. But I've been unable to really capture it. For various reasons. Here's another one too. You can clearly see the moon should only be like this big, and yet we have this whole additional layer of light emanating from the bottom of it, okay? Now, what I want to show you is this here, okay? These are my new pictures, okay? And as you can clearly see, this new picture in a different mode didn't really capture a whole lot. Like the moon was just a sliver, so the fact that it covered like easily double the moon, is just more of the same proof that I've been offering, which really isn't all that convincing, when I'm trying to convince you. But you clearly see there's an additional layer here, but it gets a lot better. We're gonna trust me, this is gonna get better. But this is, you can see this is, all right. And then there's the other one. This one looks even bigger, but you can see it's definitely subdivided into two different layers distinctly, and here's supposedly the rest of the moon right here. You can see actually the whole moon is right here. You can see it inside. The light is emanating all around it, just glowing it. But these are not the pictures that I wanted to show you. I just wanted to show you I have been taking a whole lot of pictures of this thing, trying to get it. And I have been not having a whole lot of luck recently until I took one picture. And I got one fucking picture that came out. One fucking picture that came out. This is not it. And this is not it. This is more of the same. These are, you can't even see them, the clouds though, but you really should be able to see them. But they're clouds, they're obscuring the moonlight. That's why it's bouncing all back and forth and looks like the moon's all crazy. So this really is nothing to be concerned of. The fact that the moon's all jagged in these few photos, they're not. Trust me, don't worry about that. It's really not that big of a deal. Okay, I think we're almost at the good picture though. Is this it? Okay, this is a better picture, one of the better pictures. You can clearly see, here's the moon here, and then there is a whole layer of light just nesting, glowing all underneath it, right? Okay? You can see, like you can see it. It's plain as fucking day. There's definitely something in the bottom of this very crescent moon that's glowing all underneath the moon that should not be there, okay? But that's not the picture, okay? Is this the picture? Oh, this is one of them, baby. You can see the light actually has a secondary thing on there that it's trying to capture right there. That's part of it right there. Here's the actual moon, you can see, and this little bit of a sliver of light right here is part of the effect, okay? It's definitely part of the effect. It's not a good picture of it. I think there's a better one. Let's see. See, I'm trying to hide as much light behind this pole as possible, but yet have it focused on the moon. That way, I'm taking out as much light as picture as possible. I think this is it right here. Look at it. You can clearly see there is a double moon crescent right here, bloop, and then another one, bloop, underneath it. That double moon crescent is what it looks like. It looks almost like the moon's light has been doubled, but layered, slightly misplaced off underneath it, but it's not quite as bright, and it's like wavy a little bit, and it looks like moonlight that's on fire. It's fucking crazy, dude. I'm telling you. See, you thought I was fucking cray-cray, dude. And I am cray-cray, but I'm not crazy, okay? I'm crazy like a fox, if you have to really put a name to it, alright? This is probably... Yeah, you can see this one. I think I just dipped a little bit when I took the picture. Let's test it. Yeah, you can see because this light, it also has a dip too. So this one is not good. So it looks like the best one I've got is this one right here. This double dip, this double crescent. You can clearly see that this is split. Like it's split, like right here. It's split. This is two crescents that are overlapping each other, and that's what the effect kind of looks like. Only this one's kind of wavy and not as bright, and blah blah blah. All right. And just to prove to you that's not some bullshit of the camera, if it was, here's another light source in there, it would also have a double dip on that as well, which it clearly does not. So. Just so you know, this is the best photo I've been able to take so far, proving of the phenomenon that I observe now all the time, but I never saw it my entire fucking life until, literally just a few years ago, pretty much. And now I see it all the time that we're in these solar storms that are going on, I think are causing this effect, this moonfire effect. But just so you know, so you can see, I'm not crazy. That is a double fucking... thing. I wish it was a little better picture so you could really see it. The way I see it with my eyes, if I had a better camera and I could, adjust all the settings, maybe I could get a better thing on there. Maybe you would like to think, but that's the dealio. Okay. So I just wanted to share that with you so you don't think I'm crazy, because a lot of people think I'm crazy when I talk about this stuff for some reason. They don't want to believe the things I say are true. They just don't want to believe it. They never do. Okay? So, let us continue our war on the standard model now, and let us finish this theory of neutrinos and neutrino oscillation to explain to you everything. You're probably going to have to go back and watch some of the other episode I made 2 weeks ago that's like 2 hours long. Shows you how much fucking data I had to dump on that one. I was not fucking around when I said I had to purge that shit now. I couldn't keep up with it anymore. And since I've been able to do a complete compiling of all of this data and information I purged and dumped, and I can, re-simulate it in a better way. And I believe now that I know the exact composition of every muon and tau particle, and I even know, I believe, the structure of the molecule, or of the whatever the fuck you want to call it. It's not an elementary particle because it's got other subcomponents into it. But also that I know the order of said particles and their actual spin direction. This is how deep I've gone with this shit. I've been working on this for a while, this last few months, and it's been quite a thorn in my side to finish this fucking model, this theory, and to make it completely copacetic by dynamic gravity, as I know it has to be, or it can't be real, because dynamic gravity is the only theory that can calculate gravity. Legit. Look at my math, dude. Look at my math and my papers. Ain't no one else can do that but me. I'm the only one. All the rest of them are 90% off the mark, man. So they gotta have dark matter and dark energy, dude. I'm like 3% off the mark. 3% versus 90%. Who do you think's fucking got the better math? And I can't even take credit for it, to be honest. All I did was threaten a dear imaginary friend of mine with bodily harm. And he gave me the right answer. Who knows? That's what it takes. Alright? So, here we go. Standard model. Alright? It currently says that all these particles right here are, they're all particles and that they're all elementary. Okay? This is bullshit. Half of these aren't even real. They're just a rehashing of the virtual photons they're emanating from the up quark and electrons is what most of this shit is. It's these forces right here. They don't understand how they interact when at different ranges and at different plane, what the fuck's going on, and the competition and all this stuff. I explain all this in all my papers if you care. Alright. But this is all bullshit, okay? This particle, this particle, this particle, this particle, this particle, this particle, and this particle, and this particle are not elementary particles, as the standard model says. They are a combination of particles, okay? Mostly up quark and down quark, which is an up quark and an electron. They have combined, my bad, electron and an up quark create a down quark. It's a fact. Okay? But when it comes, this is one of the reasons why I didn't dabble into this shit, because I knew I was missing elements, and it took a while before I found all the elements that go into this. But the missing element is basically fucking muons and taus are a combination of shit and antimatter, and that is very surprising. But that's the missing link. That's what you have to accept, is that matter and antimatter can play nice under certain circumstances. And I'm going to explain those circumstances, okay? But not yet. We're not there yet. This is going to get cray-cray, alright? So, one thing I want you to notice right now. The difference between a muon neutrino and a muon, okay, is -1 charge, right? And a difference in mass of about 100 plus nega electron volts. It's kind of a lot. All right, let's keep that in mind. We're going to come back to that. It's on the test. Okay. So, there's been a lot of work going on trying to prove sterile neutrinos are real. That was one of the theories they had to kind of explain neutrino oscillations and what's going on and that sort of thing. And as it turns out, all the experiments they've concluded with say that the sterile neutrinos are not real. They're bullshit. I could have told you that with dynamic gravity, but they had to spend billions of dollars to know that. So good for them. Now they know. Hopefully, or unless they're going to spend another $1 billion just to double check. Just so you know, sterile neutrino theory, pretty much dead at this point. I mean, there's still a lot of people trying to revive it, you know, and zombify that bitch and bring it back to life and, you know, feed it brains forever, but make it their little pet, like a house pet, whatever. But at the end of the day, know this, the sterile neutrino model is pretty much mostly dead, gone. Okay? So, we got muons. We got muonion, which is a positive muon in the center with an electron orbiting it, blah, blah, blah. They use that for nuclear fusion, actually. This is what I want you to realize. Okay, we take protons and we slam them into stuff, and then out of that stuff we get pions. And these pions transform, decay, create, whatever you want to think of it, into muons. Okay? This is how we get muons. Is basically highly energetic particles hit shit, and that disrupts the nucleus of the atom, the core of it, and then when it shifts to adjust, to equalize for that massive traumatic thing that happened in the nucleus of it, like having a neutron pinged out of it or whatever, slammed whatever, busted open. Then as it shifts, that shifting creates the motion necessary to duplicate or release vortex energy from a field. And it's from the Boyle-Savart law, and then that then creates neutrinos. Okay? But remember, neutrinos and electrons are like brother and sister, okay? The electron is that morsel of energy, an elementary particle for the electric force, okay? A vortex, a stable vortex for the electric force. And a neutrino is a neutron, but a neutrino is the exact same thing of that, only for the quark's positive force, otherwise known as a gravitational force by the work of dynamic gravity. Okay, so just want you to be aware of that. Okay, I'm trying to go over this up briefly so you have an idea what's going on. There's an experiment called G-2. Okay, G-2, conducted by Fermilab, right? And it was like a few years ago they did this, and they discovered that the wobble of the muon as they make it travel was larger than what it should be according to the standard model if it is like an elementary particle, right? If it's not an elementary particle, you'd expect it to have a little more wobble because it's got more shit in there doing shit, right? But if it's elementary particle, like an electron, you'd expect pretty much zero wobble. Well, they measured this a few years ago, and they measured a wobble that wasn't supposed to be there. And so they decommissioned this entire rig and moved it to Fermilab, and then redid the experiment. I guess, you know, and tightening everything down, you know, improving, making sure everything was perfect. And then when they did that, they were able to improve the experiment's results. Okay. And they narrowed it by about half. And what they got was pretty much in line with all the other experimental results of a muon, you know, as it travels its wobble. And it is I don't. It's definitely not perfect. It's definitely not what the standard model says it should be. It's not 2 perfectly like it should be. Hence G minus 2. 2 is the value of the electron, spot on. And if a muon is also just like an electron, on which a particle, it should also be expected to be 2. But they're not getting 2. They're getting like 1.996 or some shit like that. Okay. Very close to 2, but not 2. But because of the experimental error they claim they must be going on, they say that, well, it's plus or minus this much, and so we believe this falls within the limits or the scope of the standard model's predictions. Okay, fair enough. I just want you to know that this experiment is important for a couple of reasons. Number one, it did demonstrate that there is a wobbling going on with the muon that should not be there. And nobody knows why. Except for allegedly an octopus with 7 arms. Because he fucking lied to me once. And he told me everything. So, yes. If you have multiple things making up a muon, it's going to wobble. Particles wobble. They're not perfectly steady like the vortex of like an electron or a neutrino as it would travel, okay? So, just know that. This experiment proved there was a wobbling of the muon that should not be there, but they say it's within tolerances, so it's not a big deal. Now, there is something else that came out of the muon G minus 2 experiment that's very important for us that we need to understand. Okay? And what that is virtual protons. Yeah, see, these are just theories trying to explain stuff. Okay. No, I thought there was something else important here, but maybe there wasn't. Yeah. Okay, we have to do this. I thought I had this, but apparently I fucked this up. Unless it was on this one, which definitely was not. So, yep, I fucked this up. Okay, so we're going to have to find this thing, okay? What it's basically saying, what I'm trying to find here right now, is it says some here that, here we go, that's what I'm looking for. When a muon decays into an electron and 2 neutrinos, okay? We're going to look at all this past shit, don't worry. I just want you to know, the electron tends, more often than not, usually, pretty reliably, to shoot off in the direction that the muon's spin was pointing. Okay? So, what does this mean? This means, what is this? This was last week's episode. Something, okay? We have a muon, okay? Boop, beep, bop, beep, boop. Okay, and the muon's going this way, alright? When the muon goes and it decays into multiple things, like a neutrino, an electron, and a muon neutrino, if I'm not mistaken. Excuse me, anti-neutrino. That seems about right. These things go whatever direction they feel like. Beep, bop, beep, boop. But the electron tends to go straight. Alright? So, the muon was going this direction. Its spin was going this direction. That's why it was going that direction. Particles tend to go the direction of their spin unless you make them do otherwise, and that causes funky things like antimatter. Alright? But all these particles that come out of this, they just go wherever the hell they want. But the electron always wants to go straight. Okay? It's the basis, the base of the muon particle. Okay? It's very important for what we're doing here. The electron is the base for a muon electron particle. Okay? This is important. Don't forget that. Okay, we're going to look at that later. Okay? Here's a reaction I want you to be aware of too.
Fraction
okay?
of those neutrinos collide with a neutron. One possible reaction.
So this is a muon neutrino, okay? And it is colliding or coming nearby, whatever they say. I showed these reactions in the last video. And what's going to happen is they're going to claim that a boson is emitted from the neutrino and then hits the neutron, and then this changes everything because magic! Pixie dust! That's what they claim.
Is for the neutron and muon neutrino to be converted into a proton and a muon. The muon zips off through the oil at near the vacuum speed of light. In fact, the muon is moving faster than the diminished speed of the muon.
So, I want you to know, what we started with was a muon neutrino. And what we did was we turned a neutron into a proton. Okay? Now, according to dynamic gravity, a down quark is an electron and an up quark that combined. And this is evident because almost every fucking time a down quark decays, it decays into a electron and an up quark. Okay? And the up quark is positive, the electron's negative, they want to be together and they just suck together, all right? But the charge is not balanced, so it's off, so you need more. So the way it balances out is you get 3 up quarks and 1 electron, otherwise known as a proton, which is also considered 2 up quarks and 1 down quark. Remember? A down quark is an up quark and an electron. So really it's 3 up quarks fighting for the love and affection of 1 electron in a gangbang. That's what a proton is. Okay? That's what's going on. Now, a neutron is a different beast, okay? There's a thing called electron capture, and this is when a proton captures, gobbles up, eats an electron. Now, we change the charge distribution. We now have 3 up quarks that make a combined thing, a charge of like 2, and then we have 2 electrons, which have a combined charge of -2. Positive 2 and -2 cancel each other out to make 0. Fact. Now, we have 3 up quarks and 2 electrons and a neutron. So the difference between a neutron and a proton is that extra additional electron. Okay? So, when you see a reaction like this, a electron, muon neutrino that is changing a neutron into a proton, an electron is being stolen out of that neutron. And that's why it's reverting into a proton. Okay? Keeping up? So, that electron is now getting eaten by the neutrino, the muon neutrino. Okay? And what the reaction is
into a proton and a muon.
A muon electron. So what I want you to know is that not entirely, but almost entirely, the only real difference between a muon electron and a muon neutrino is 1 electron. If you rip that electron out of the muon electron, you now pretty much have a muon neutrino. Okay? And if you give that to a muon neutrino, now you make a muon electron. to understand this. Very simple, right? You see what we're doing. Now, let's go back to our pop quiz I told you we were definitely going to fucking have. We have a difference here, right? But this difference is actually far worse than you think. Because according to dynamic theory, electron neutrinos are the same mass and size as electrons. We just can't measure that because it's made of gravitational potential energy. And we are living in a vast gravitational field. So it would be like trying to measure a drop of water, of like clean, fresh water, in the bottom of a diver at the bottom of the salty ocean. It's like the drop is there, man, but it gets dissolved and whisked away and overpowered by the metric tons of salt water on top of you. You're never going to see it. There's no experiment you can do to measure that, man. And this is the same way when it comes to trying to measure things like neutrinos. They do have mass, like an electron. They are affected by a gravitational field, like an electron is by an electric field. But they're not... It's kind of different, though. It's hard to explain, all right? So that's what I want you to realize, is that the difference between this bad boy and this bad boy is 1 electron. That's it. But if we do the math according to standard model, this doesn't fucking add up at all, because this is half a mega electron volt, yet this bitch is like 100 electron megavolts. This one's not even 1. The charges, when you try to convert mega electron volts into mass, I don't even know if that even works out very well. But then when you try and convert mass into... You have to understand what mass is. Mass is how much something is affected by a gravitational field. Okay? And when you have a particle like a neutrino that's constantly going the speed of light, it's going to be messed up. It's just not going to work, man. It's not a good way to think about this shit, so I'm trying to tell you. So when they tell you all this shit in the standard model, like, we know this is exactly blah, 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 they're just doing experiments, and those are the results, but they're not really, that doesn't tell you they're interpreting the experiments properly, because they don't even know what the fuck they're looking at, okay? Do you remember that? They don't know what these particles are. I do. They have no fucking clue. They think all this shit is just pixie dust with fucking energy levels thrown on top of space-time and that. That's all they can say, and it makes no fucking sense at all. But they don't care, dude. They don't care about the truth. Or they would have figured this shit out years ago. Alright? So, we got that experiment. Alright? And there's another one too that I'll show you later, but okay. And then here is something that is important we need to know, like when they make pions, okay, and the pions turn into muons, okay. Usually they're positive pions, mean positive muons, and you can see here, this pion is designated by a up quark and a down quark. There's an anti-down quark. I mean, it is a down quark made of antimatter. And since, remember, a down quark is a up quark and an electron that combined, what they're really saying this is this is an up quark, a regular up quark, with an antimatter up quark and an antimatter electron, which is a positron. Okay? So those are the 3 particles that are making up this pion. Okay? I need you to be aware of that. And this one, it is reversed because it's a negative pion. So this one has a down quark, which is a up quark and an electron, which will have a negative charge. Why is it a negative charge? And a up quark, an anti-up quark. So antimatter up quark. And I explain how all this stuff is made and other videos and everything else. If you look, I have so many videos in this fucking channel now. It's insane. It's really stupid. Okay? So, that's Idealio. Alright? Additionally, before we really dig into this head first and really start whacking heads, these are the two biggest accepted decay paths for muons. Okay, here's the negative muon. Remember, the negative pion creates a negative muon. Okay, see, look, negative pion, and it goes into a negative muon, and this is a anti-muon neutrino. So this creates a negative muon and a anti-muon neutrino. Okay? But that's not even it. Okay? But then we go further and see, here's our muon. Okay? This muon neutrino, this is the positive variant, not the negative. That's why it's not an anti anymore. Now it's a positive, not a negative like it was before. So now it's a regular muon neutrino, and this is a positive muon. And this positive muon will decay more often than not into a positron, an anti neutrino, a muon neutrino, my bad, an anti-muon neutrino, and a regular neutrino, an electron neutrino is what it's called. Okay? So just know that these are the accepted fucking decay paths of this particle. So when this particle just gives it all and shits itself, it's like, that's it, I'm done. This is what it turns into. It breaks apart into these things. Okay? And of that, only the electron retains the momentum of the particle that it had before. These other two particles go off randomly. Okay? That's important. We're going to get on this shit. It's going to be fucking cray-cray in a second. Before we do, I need to refresh. I'm drinking like a fucking fish today, man. Woo! How you guys doing? Doing alright? Hope so. Alright. So, I'm going to show you something that is worthless now, but hundreds of years from now, people will go ape shit over this. So, feel privileged that you get to see it early. All right. Here we go. Here are my notes. This is my notebook. I started keeping about 4 years ago. It is about 4 years worth of notes for me. Okay. You can see it's a lot. You can see I've been pretty busy. A lot of stuff that I've had here. A lot of stuff that I've had here. A lot of stuff that I've had here. You can see I'm a busy boy. Some of these are dead ideals that I've proven wrong. Some of these are ideals that are curveballs I'm about to throw at your ass that you ain't even going to see coming yet for a while. But that's it. If you ever cared about my notebook to see how active I am and how much I dig into shit, now you got a clue. And that's not even all of it. There's another one too. Older one. Okay. So, this is what we got for muons, alright? This is my muon oscillation. Okay? A muon decays into an electron in two types, okay? So here's the decays that we went over, okay? Here's that decay paths. All this is saying is these are the two decay paths. So we know a muon is essentially made up of these particles, these three particles. Like a negative pion creates a negative muon. And then that creates, you know, these three particles somehow combine and create a muon. Okay? I'm about to dig into this shit. But we got a problem. if you're clever, you might have already noticed it. It took me a day to figure it out, because I'm not the cleverest. We have a muon, and it is turning into an electron, which we know is the difference between a muon and a muon neutrino. And we have a muon neutrino coming out of this bad boy, which is really good. All right? So that's really good. And then we got an anti-neutrino. All right? So that seems to add up, right? But then, if we try and figure out a decay path and go backwards from this and balance out the equal sign, we basically say that a muon neutrino will always shit out a muon electron when it decays. And now you have this infinity loop. The infinity is not real. I'm just proving this again and again in my channel. I've made videos about this. Infinity is a mathematical, man-made, hypothetical concept that does not exist. It's like saying, like, but what if you have an island with like 40-foot tall elephants? And it's like, I mean, yeah, that'd be interesting, but there is no such said island, so shut the fuck up about it. Kind of where we're at. Alright? Now, so the way we deal with this infinity loop, the way I dealt with it, is I said, what is this math trying to fucking tell me? It's telling me that there's something going on with this bitch, alright? Because if we look at the pions, the pion allegedly claims it decays. It's just an up quark and an anti-down quark, right? But it will decay into a muon and a muon neutrino. But then the muon will decay into another muon neutrino, and the muon neutrino will decay into a muon. And it just keeps going back and forth, and it's infinity, and while it's doing it, it keeps shitting out these various particles on top of that. None of this, it's all bullshit. And that's probably one of the reasons why no one's ever thought about this before, because when they try to add the math up like this, they did it at this superficial level, and nothing added up. I'm like, well, clearly that doesn't work out. If you do it wrong, it doesn't. So what's the right way to do it, you might be asking. After a lot of study, here's what I believe is a muon electron. This is, I believe, the makeup, or the composition, the structure, and the order and orientation of spin. So there's a lot this little thing is showing you, okay? These are the other two variants I had to hash through that I believe are not it, which were possibly could have been it, but I don't believe they were. But I had to hash through these. These are the other two, so don't worry about this stuff over here. This side doesn't make any sense, alright? This is stupid. But I got this arrow here, because it's telling you what direction this particle is going, okay? So it's going this direction, okay? It's going this towards the direction of the arrow. So that's the direction of momentum. That's the direction that the electron spin has to be going, and the electron wants to go. We know this because it has to be that way. Otherwise, it's impossible for the electron to keep going that same direction from the G-2 when they measure it and it decays into these particles. All right? So, what this basically is, and I want you to think about it, this is pretty radical, right? We know that a muon will decay into an electron, an anti-neutrino, and a muon neutrino, okay? So, here's all the particles right here. And the neutrino, we can see, is reversed. Here's a neutrino particle. And the anti-electron is reversed, and here is the anti-electron particle in the tau. Okay, here's the tau, here's the muon. Okay, so they're both going this direction, right? Now, what this is, this thing right here, this is a muon tau particle. So a muon electron and a muon tau both have a muon tau particle embedded into it. But when it decays, like the muon decays, the electron breaks apart from the tau, and the tau during this process will become unstable and shit out the anti-electron, neutrino, right there. The that's what's happening right there. So that's this particle right here, okay? Anti-neutrino. And it's going to be going this direction. So this whole particle is fucking crazy, man. This is going to be crazy. Just explaining this is making my head spin. Let's go to the muon neutrino, okay? Here's a muon neutrino, okay? And a tau neutrino. And you can see what's going on here is we have a pion, essentially. We have a quark and a anti-quark, okay? But there is no electron or positron, so this is not a pion, but it is a quark anti-quark combo, okay? And both the quark and the anti-quark are they're not going into each other. If they're going into each other, they would probably combine, and then the currents, because the quark's current is forward and the anti-quark's current is negative, when you put them together, they want to equalize out, and that releases all the energy instantly, which releases, gamma photons, which is why we know a typical antimatter reaction. When you pit antimatter with matter, it explodes and converts into 100% pure energy. That is true. Now I just showed you why that happens. Okay? So, if they are facing each other, we would definitely expect this reaction to happen. But they're not. And there's also things that can happen to nullify stuff, if that makes any sense, okay? So, both of these are going with the momentum and the direction of the muon neutrino, this direction, okay? But this neutrino that is in this particle, the only elementary particle in this besides the quark anti-quark pair is the neutrino, the electron neutrino. And that wants to go the other direction. That's actually reversed, which means its momentum, its spin is the opposite direction, okay? So, it wants to go backwards, but it can't because both of these are in front of its way. And they're pushing, right? And the quarks are bigger and have a faster vorticity than an electron, and I believe a neutrino as well. So a quark is always going to win that battle. Okay? So, and because this particle, they are lined up like this, like in a row, this makes the particle that if the particles are aligned in the same direction, have the same spin, which they do, for these two anyways, this means two things. A, it is now possible for this particle to travel near the speed of light, or at the speed of light, and this particle I forgot what else I was going to say. I'm already blitzed. What I'm trying to say is, if you have a molecule like a neutron, okay, and where a neutron is. A neutron is 3 up quarks and 2 electrons. Okay? They're going to be fighting each other like this, okay? The direction, the spin, the momentum of these particles are going to be all over the fucking place as they're fighting and bouncing around. Maybe not so much in a neutron, but definitely in a proton, 100%. A neutron will definitely happen too, but so what this means is that this particle cannot travel the speed of light unless you dump a fuck ton of energy into it. Alright? Because this particle is fighting itself. It just wants to stay still. So if you push it, it'll go. If you hold it, it'll stay. Okay? Where you have like an electron or a neutrino, or even just a basic quark, it's just an elementary particle. It's a vortex. And when you have a vortex, I know, I'm so bully with all this stuff, blah, blah, blah. Okay, look, see that vortex? He popped it out of his mouth, and then pushed it, and the vortex is spinning this direction, okay? And so its spin is going this direction, technically. If we're going to relate it to like an electron or a quark, okay? That's what the spin is, the vorticity. That's why they say the particles are indeed spinning, but they know they're not spinning like a ball is spinning. You know, because it's a fucking vortex. It's a donut. It's a tori. It's a toroid, whatever you want to call it. Not the same. All right? So, as it's spinning that way, it wants to travel that direction. Electrons and quarks and neutrinos are the exact same way. Okay? As long as it's spinning that way, it wants to go that way. The spin determines the momentum or the direction that it's going. Okay? So, just want to make sure I got that. Okay? So, now that you understand what I'm talking about, when I'm talking about this, if a particle is going to go the speed of light, and it is not an elementary vortex particle, like an electron, a neutrino, an up quark, then that is impossible unless one of two things happen. You force it to go the speed of light with a butt ton of electricity like you do in a particle accelerators with the magnetic fields and electric fields, or dumping all that energy to make those, protons or electrons, whatever they're doing, travel around as fast as they can. Then you can go like 99.999 the speed of light. Okay? You can do that to like a neutron. Maybe not a neutron because it doesn't react to the electric field so much, but like a proton. They lower the protons, right? That's the only way you can make a proton go that fast, okay? Normally, protons don't want to go that fast. They can go pretty fast, don't get me wrong. I mean, these vortexes want to go the speed of light when they're left alone. So just because you got a few of them fighting doesn't mean this particle is just going to stay still and go like maybe 1 mile an hour. No, it's going to... It's just not going to be going anywhere near the speed of light. Okay? Because there's too much resistance, too much fighting going on for what direction it should be going. Okay? They can agree. But if all the particles are in line, now this particle, if they're all in line and the majority of them are going this direction, now this particle can indeed go near the speed of light. Because that's how fast it wants to propagate. From, I think, Maxwell, calculated that. So, that's how we know. Because we know neutrinos they want to go the speed of light. If they're left alone, they want to go the speed of light. So, we know, like an electron, If it's left alone, it wants to go the speed of light. If you start fucking with it, all of a sudden it slows down and it does chemistry. All right. Photons always want to go the speed of light. They never want to slow down because of they never go away from their waveform. If that makes, I explain all this in the videos if you give a shit. So, what's going on with the neutrino oscillation, you might be asking. Okay, I've told you what a muon neutrino is, and I've shown you the structure of it and how it's laid out, and I've shown you the direction of the spin for the particles. Okay, the quark and the anti-quark are both going this direction, but this neutrino is going this direction. It wants to go that direction, and that's helping keep the whole particle together, having them want to meet. Okay? Now, according to dynamic gravity, the way that you make antimatter of anything is you take a particle and you drag it against its momentum, against its spin. So if it's spinning this direction and it wants to go this direction, it's like it wants to travel the speed of light this direction, like it's an electron, and you say, nope, fuck you, and you grab it with like a magnetic force or something, a magnetic field, and you say, fuck you, and you drag backwards across the energy field. Now that will create, if you do with enough energy, it will create a vortex in that field. And that, what do we know particles are? They're vortexes. So you have now created an identical particle with that energy you put in to drag your electron or quark backwards against its momentum. It will now create an antiparticle. And if you want to create a particle, you just drag it with its momentum. So you could either flip it and then reverse drag it, or you could just push it, whatever, and then pull it back. Like bloop, bloop would make a particle. Bloop, bloop would make an antiparticle. Catch that? Bloop, bloop, particle. Bloop, bloop, antiparticle. Did you catch that? Did you catch the hand trick? Okay. So, that explains that. Alright? Now, why do I tell you this? Because you have to know it to understand what the fuck's going on here. Okay? Only dynamic gravity can explain how a fucking muon neutrino can turn into a tau neutrino. They're almost the same. The only difference between the muon neutrino and the tau neutrino is this one motherfucking dude right here. That's it. And he is an anti-neutrino. And his momentum is going to be going with the particle. So in the tau, everything is going with the particle except for this one motherfucker right here. This neutrino. This electron neutrino. Okay? So, you have a muon neutrino. And it is pushing, these two quarks are pushing this electron neutrino against its momentum. What can this do? This can create another vortex if it's going through a strong enough of a gravitational field. Because remember, that's what neutrinos are more affected by, the gravitational field. See, look at this, I wrote it down. Would be affected by gravity field. Where a muon, because its base particle is an electron, it's going to be affected by an electric field. Okay? And we're gonna dig into all this shit. We're not even fucking halfway there yet, my son. This is gonna be a long episode too, just like the last one did in neutrinos. But the difference is, we are gonna have climax, we are gonna have the money shot, we are gonna have complete resolution. I'm gonna get you there. Okay? So, that's the dealio, okay? So, when you drag this motherfucker against his momentum, over time, eventually he's going to accumulate enough of a field that he's going through, he's affected by, which is a gravitational field, that it can create another particle. But the particle has no other orientation to be than to be the opposite spin of the particle that created it, because they're going to be some sort of entangled state, so to speak. And I forgot what I was going to say. So, okay, as this particle travels through a gravitational field, it can accumulate enough gravitational energy that it can manifest another vortex that's created dragging against the polarity or against the momentum of this neutrino, which means the new particle is going to be an anti-neutrino with the anti-spin. So, now we have this new particle that's created just by traveling a muon neutrino through a gravitational field. Okay? Not a regular neutrino. I want to make you understand this here and now. There is no way in my theory to explain how a common electron neutrino could oscillate into a muon neutrino or a tau neutrino. I cannot do it. It's impossible. What I can do is I can totally explain in copacetic agreement with dynamic gravity and the rules it plays by how I can make a muon neutrino oscillate into a tau neutrino, which will then become unstable and shit out a regular neutrino. So I can make a muon neutrino into a tau neutrino, and I can make a tau neutrino into a regular neutrino. But I cannot make a regular neutrino, a neutrino electron, into anything else. It is an elementary particle. It is not going against momentum. It does not want to fucking do that. It is not going to. It is what it is. Okay? And you cannot change, like an electron. You cannot change an electron into, a muon. It doesn't happen. And neither does a neutrino. But as I went into and alluded into the last lecture I did on this neutrino oscillation 2 weeks ago, there's only one experiment that even alludes, possibly, that neutrinos can convert into muon neutrinos. And the way it's done, you have no way to determine what's what. And that's the only one. That's the yes and no. Okay? And I want you to remember it too. Remember when I said the difference between a neutrino, a muon neutrino, and a muon is an electron. Okay? Here is the SNO, or LNSD, my bad, that experiment I was talking about. And we have a muon and a neutrino plus a neutrino will turn into a muon and a proton. So remember, we're stealing an electron from the neutrino, and that turns into the proton. Remember, and then the muon neutrino gains an electron, and that turns to the muon. But it also not only gains the electron somehow, I don't know how. It's also got to gain the anti-neutrino, because that's also a part of the muon. It's right here. Okay. You have to remember, the difference between a muon electron and a tau electron is not the same as a muon neutrino and a tau neutrino. Okay? The difference between there is the positron. All right? Well, actually, so is space. Okay, so now let's go to an anti-neutrino. Okay, and just so you know, guys, I'm not 100% done with this. I think I might be wrong on some of these orders, and there might be something else going on here, especially for the tau versus the muon. But we shall see. So, the muon anti-neutrino, okay, it is like a muon neutrino, only it's vice versa, and that the main particle in it, is not a neutrino with a anti-quark and a quark. It is an anti-neutrino with a quark and an anti-quark. So that's the only difference. You have neutrino versus anti-neutrino. And this works exactly like the muon neutrino, as it turns out. As long as you reverse the order of the two quarks, so that, because you gotta remember, according to dynamic gravity, a muon actually has a neutrino actually has like a positive charge. So an anti-neutrino actually have a negative charge. So it's actually going to want to be associated not with this anti quark, but with the quark itself, because the anti-neutrino technically is like a negative type particle, and the quark is positive, so they're going to want to stick together. That's why they want to stick together, okay? But remember, according to standard model, all neutrinos are completely neutral, but that's just because we can't measure the gravitational charge that they carry, because we're in such a massive gravitational field, if that clarifies it, okay? But and then we have, of course, the positive variant of the muon electron, okay? And the way the positive variant works is very similar to, of course, the muon neutrino and the anti-neutrino. You have to swap the order of these two quarks, okay? Otherwise, it does not want to hold itself together. But if you swap the order, and now all of a sudden everything works out just the exact same as if you were to have the negative muon electron variant. The only difference is, for this one, instead of having the electron being the particle that holds it together, what you have is the positron. So instead of a negative charge, it's going to have a positive charge, okay? And I did just notice one thing. It seems like the charge of the tau electron versus the muon electron would not add up to be -1 according to this. So I'm going to have to go back and look at that. Maybe it's because I'm drunk right now and I forgot what the trick was to justify that, what's going on, but I'm going to have to figure that out. I'm not doing another video about this shit. There's just so much to this, dude. Do you see what I'm talking? There's just so much to this. It's insane. And it's like, I have a short attention span. I can't keep track of all this shit forever and ever and ever. But I am confident this is like 99% correct. Alright? But if we reverse for the positive muon, and just basically swap out the electron for the positron, which is the difference between the two, because remember, the pions that created it, we have a down quark, an anti-down quark, which is a positron for the pion, positive, and a regular down quark, which is an electron in that bad boy for the negative pion. So, I can explain all of this stuff, alright? So, there is one thing you guys might notice, right? Some of these particles, like, say, these two neutrinos, right? We got a positive neutrino and an anti-neutrino, or like a regular neutrino and anti-neutrino. Why do they not explode immediately. Okay? And then we got things like a quark and an anti-quark. Why do they not explode immediately? Okay? When they touch anything. Antimatter with matter, right? It matters what kind of matter it is, an antimatter, right? So, first of all, we got an anti-quark right here, okay? The anti-quark can absolutely 100% play nice with the anti-electron because they're both negative currents. So they're both the same direction of current. They can touch, no problem. This is not a deal. But the the electron and the quark touch, right? Because this one's positive and this one's negative, and they naturally want to be attracted to each other to touch, right? Even though they're negative currents, what you have to remember, like one's a positive current, one's a negative current, so you put them together, you expect them both to cancel out and explode. But that's not what happens, because the quark is a completely different energy signature than an electron. An electron is essentially an electric field confined by a magnetic field in a vortex format. That's what an electron is. A quark is a gravitational field confined by a gravimetric field in a vortex format. That's what a quark is. So, the electric field and the gravitational field, they attract, they interact, they do things, but they aren't the same thing. So when you have a positive variant of one and a negative variant of the other, they're not going to immediately cancel out and explode. This is not going to happen. So, this electron and this quark, or my bad, this anti-quark and this electron, if they touch, are not going to explode and destroy this matter. They can interact, okay? But these two, like if this right here, like if this electron and the anti-electron both touch, they're both negative current. If they touch, they're both going to have to cancel out somehow, right? Or vice versa with the neutrinos, the neutrino and the anti-neutrino, okay? Big explosion. But there's something going on here, okay? There's two things going on. First of all, remember, like I said, neutrinos do have a charge. They're not chargeless. So this neutrino is going to want to be interacting with this quark. They're going to want to play together, which means this neutrino right here isn't going to get the opportunity it would normally have to play with this other anti-neutrino. Or if we just want to go here to neutrino. Okay? They're not going to have as much opportunity, the same type of opportunity to play nice together, because these two are already playing together. And because, like, when you have a magnetic field, right, and then the magnetic field all shifts to another magnet, right? So it's all in between the two magnets. So the field is going that direction, and that is messing with this particle's ability to interact with it. Also, there's something else, and I believe this was sent to me by God, and he sent me this a few days ago to help explain this, also what's going on. These two particles have two different lives, okay? They have a life when they're stagnant and sitting still versus when they are traveling very fast, like the speed of light. Okay? Let's see if I can't find this bad boy here. Is that it? Yeah, that's it. Okay, so you have two wires, okay? Let's say both wires are positive, and they're both going the same direction. The wires are going to repel each other, right? Both wires are positive. They don't want to play nice together. But now you send a current, and the positive current is traveling through these wires at the speed of light, and now you got a magnetic field being generated from this. The orientation of the magnetic field from the right-hand rule now says that these two wires, they're both the same polarity that don't want to touch, because of the electric field they have, the magnetic field is the exact opposite. It's saying, fuck you, we're going to touch. And so these things, as you power them up and make charges, positive charges through both wires travel through them, now they naturally suck together because the magnetic field pulls them together even though the charges are repelling them. Okay? This is a thing. This happens. And if they are going opposite directions, like the current of the wires. So let's say this one's positive and this one's negative. They naturally want to touch when they're stagnant, when they're not moving. But the second you charge them and have current going through them very fast, creating a magnetic field, the orientation of the magnetic field wants to push them apart. Okay? So, this is what particles are. They are fields confined by magnetic fields or gravimetric fields, depending on what the particle is. So what I'm trying to say is you can have two particles that normally would not touch, but now they are stuck to each other because they are now traveling at the speed of light, which is what we've discovered neutrinos want to do because of the orientation of the linearness of the module and how the spins are oriented. They want to travel at the speed of light. And when they do, that completely reverses all the interactions that are going on between the positive and negative charges. So, you have positives that now want to stick together, and you have, let's see, we go here too. Here's another example of this, same thing, just wires, different velocities or directions of the wire's current determines whether the wires go apart or whether they go together. Okay? Excuse me. Drain damage from the war. Sorry. Game of death. It's a motherfucker. Tell you what. Oh. This motherfucker. Okay. I'm good now. Let's see here. I thought there was... Okay, that's something different. Alright. So, let's go back to... I'm going to shizzle my nizzle, okay? So, what we've got here is like these particles, right? Normally, you would expect the neutrino and the anti-neutrino, because they're opposite polarities of the same particle, so when they touch, big explosion. The same with a quark and anti-quark. They're negative. Like one's positive, one's negative, so you'd expect for them to want to come together, and then when they touch, big explosion because the currents counteract. Okay? But as I just explained to you, there's another fucking layer of this onion that is going to make you cry. And that is that these particles are not static. They are indeed traveling near, if not the speed of light, which now essentially kind of reverses all the interactions of how these particles want to play nice together. Yeah. This shit has been fucking making my head spin, okay? It just keeps going and going. This neutrino rabbit hole, man. It's absolutely bonkers. But there is also one more decay path I think is important here. And for the muon, it can also decay into an electron and 2 gamma photons. Okay? Remember what we said. We said a muon is an electron. Okay, there's our electron. And then we have 2 neutrinos, which are essentially electrons, only variants of the quark field and not the electric field. Can be converted into photonic energy easily, though. So this can easily explain how we get an electron and 2 gamma rays. But the 2 quarks, they're not measuring for whatever reason for this particular decay path. I don't know why. Maybe these are indeed canceling each other out, interaction, and creating a completely different type of energy signature, gravity base that they're not looking for. Completely possible, because remember, these are gravity particles. These are electric. My bad. This is an electric particle, the electron. All the rest of these are essentially kind of gravity-based particles. So, but the neutrino and the antineutrino are equivalent to an electron. So things can happen, is what I'm trying to say. All I'm trying to say is this right here totally explains everything. All right? At this point, I am 100% convinced that all of these are good. The only thing I'm having doubts with right now is this one fucking positron being added on to the tau, because for some reason I'm not adding up right to the right charge of the tau. I think I might have fucked that up somehow, but we'll see. But everything else I think looks really good. And then also, something else I want to explain to you. One reason why the muon does not transmute into a tau is because as it travels, the electron is indeed going the direction of the momentum. So it's not going to make an anti-electron if it were indeed to even accumulate any charge at all and make an additional particle, like an additional electron or something. If anything, it'd be a muon shooting out an occasional electron once in a blue moon. It would not be like the muon neutrino, which is actually being dragged against its momentum to create the antimatter variant of it, which is the antineutrino, now making a completely different particle that's in the fray of that. Okay? So, man, I think I've hit most all the points. I'm sure I've missed a few because this has been going on for like an hour and a half now, and I am not gonna lie, I'm blitzed. My head is spinning. I'm fatigued. I'm seeing double vision, and I just I'm gonna take a break. But I might do one final video to address the final tau situation. Other than that, I think everything here is 100%. I believe this is what's going on with neutrino oscillation. And this is what muon and tau particles essentially are in this specific order and spin orientation. I have yet to see anything that's convincing of anything. Like, I'm sorry, but the standard model doesn't add up. It's bullshit, dude. It's bullshit. You should question it. You really should. There's no reason you should. It is incontrovertible, or you can't question it, and you know you can't. You're not allowed to ask questions of it. It doesn't add up. It's bullshit. None of this shit adds up. I can make everything add up perfectly with dynamic gravity, okay? I can make the whole universe make sense with dynamic gravity and have math that perfectly explains everything. What more do you want? Like, seriously, what more do you need to question the current status quo that ain't working? Anyways, I hope this settles almost entirely the dealio, so everybody knows what neutrinos are, what electrons are, what muon neutrinos are, what muon electrons are, what tau neutrinos are, and what tau neutrino and tau electrons are, and what's going on and why they behave the way they behave. There's a whole smorgasbord of interactions and shit going on here, which is one of the reasons why this has probably been the hardest test for dynamic gravity for me to deal with. Because there's so many things. I mean, look at this. This shit has been like two 2-hour long episodes almost. I mean, this is like insane. This is insane compared to any other concept I push forth with dynamic gravity. But anyways, I'm gonna call it right here, and I hope you learned everything that I intended to teach you today. If not, there's always another day. I ain't dead yet. I got another year till I'm dead and gone. You got time. Chill. Just chill. Until then, Akamalaka, my brothers. Peace out. Howdy. I just had to issue an official correction because it wasn't selling right with me. The charges weren't adding up, and you know, I mean, I'm a mathematics fanatic. The math has to add up, or I'm just not. I don't believe me. And so I did a quick look, real quick, and what I found was here is the decay paths for taus, right? Tau muon, tau electron. And you see, here's goes by pion, just slamming it in the shit, all sorts of crazy shit's happening. But this looks like the main decay path, the big one. A tau will turn into a tau neutrino, an anti-electron neutrino, and an electron. Okay, so the electron is still the core particle. You got an anti-electron neutrino being shit out there, like from a muon electron as well, when that decays. And then instead of having a muon neutrino, you have a tau neutrino. So it's suggesting that the only real difference between these two particles, between a muon and a tau electron, is indeed just the neutrino, whether it's a muon or a tau neutrino that's embedded into it. Oh, that's not. There we go. But I revised this real quick. I eliminate the positron because I was making the charges not add up. Now everything adds up copacetic. I think this is probably the way it's. I don't know. Before I was like drunk fucking around. I think I forgot I did that. But so yeah, basically, a muon electron is essentially just a muon neutrino with an electron attached to it. But when it breaks, because this neutrino is being dragged against its momentum, its will, if any reaction causes it to readjust, it might cause it to shit out another particle. That particle is going to be a anti-neutrino, which is what we see coming out of that when it decays. So I think that was the hang-up before. And then for the positive variant, it would shit out a neutrino. So let's check that. If we go to the positive, we have an anti-neutrino, muon neutrino, with a positron. And then when it's seeing it's dragged its will, turns to a tau with a neutrino. But then when it decays the muon, it will decay into a neutrino, theoretically, because this would shit out a neutrino particle, but it wouldn't dissolve away. And so that seems to be the dealio, what's going on. So I think this is the way it is. I think basically a muon neutrino is just a quark and an anti-quark with a neutrino. A tau neutrino just has an anti-neutrino added to that bitch. You add an electron, and now you got a muon electron, and you add one more, or you make it a tau instead of a neutrino. Muon neutrino, you make it a tau neutrino, embed it into it with that electron, and now you get a tau electron. I think that's also going on, and that seems to work out perfect for all of the variants we have of tau and muon neutrinos and electron particles, one that we know of. So I decided to put that correction out there. Because it wasn't sitting right with me, and I knew as soon as I was reading through it, now even though I was drunk as fuck, I was like, yo, something right about this math ain't adding up. I have to fix this. And so I fixed it. It took me 3 minutes. So that's the official synopsis put out by Dynamic Gravity. If it changes, I'll put out another video and let you know, but I think this is probably the official legit thing that's going to be pushed forward in my final paper. I think this is how it's got to be. It just has to be like this, or it won't fit at all, according to the framework of Dynamic Gravity. And Dynamic Gravity we know is true because it literally solves every conundrum and problem in all of physics. I mean, there's nothing that it doesn't fix. So it has to be true. So I think that's the dealio. I just wanted to put out that quick official correction before I publish this video, because I don't want to push out shit that I don't believe. And I know those charts weren't adding up just a second ago, and so now they do. Now they look good. Now I believe it. Now I'm good. I hope you learned something. Until next episode, God knows what it'll be. Who knows when it'll be. But adios, muchachos. Peace.
Like, subscribe, submit.